Hello, I'm Dave Messersmith with Penn State Cooperative Extension, and I'm back again with Dr. Terry Engelder. Terry is, of course, a professor of geosciences here at Penn State University and one of the leading experts on Marcellus Shale geology. So Terry, we're glad to have you with us today. Thank you for your time. The topic we want to cover with this clip is recoverable reserve estimates in the Marcellus. And maybe Terry, if you would first explain what is a recoverable reserve, what is the definition of that, and then maybe give us your current estimate of what the recoverable reserves are in the Marcellus.
Yeah, certainly. The thing that brought the attention to the state of Pennsylvania, at least for the Marcellus, was the Penn State press release of January 17, 2008. In that release, I was quoted as, I, along with my colleague Gary Lash at SUNY Fredonia, we were quoted as saying that there was as much as 500 trillion cubic feet of natural gas in the Marcellus, of which 10% of that was technically recoverable. That original calculation was based on the thickness of the unit and a number of other geological parameters. There was no production experience at that particular point in time. That was a particularly conservative number because we minimized the thickness. We took a smaller area than one ordinarily would. We had a lower porosity. We affected a number of parameters that eventually, when Chesapeake came out with their estimate for each of these parameters, what we did was we multiplied those parameters together and came up with a number that was considerably larger, somewhere between 3,000 trillion cubic feet, 4,000 trillion cubic feet of gas in place. Now, if one takes a technically recoverable volume from that, 10% of 3,000 trillion would be, of course, 300 trillion. That was all a set of calculations known as volumetric calculations, not permitted by the SEC to book reserves based on volumetric calculations. In order to demonstrate reserves, according to SEC rules, one has to demonstrate productivity of the natural gas. And in doing so, then a company, an operator, would develop curves that are called decline curves, where gas at its highest pressure produces most rapidly, and as the pressure falls, the gas production slowly falls with it. And once a history of production is developed over a period of months to years, then one can use that decline curve to extrapolate toward an estimate of the expected ultimate recovery, EUR. And the EUR for many of the Marcellus wells is in the billions of cubic feet. And so one then can make a resource calculation based on the statistics of production in the Marcellus. And I did so for the Fort Worth Basin Oil and Gas magazine. I did this in August of 2009, and that estimate based on the production curves for the Marcellus was that technically recoverable gas would be on the order of 489 trillion cubic feet. And because this is a statistical estimation, then we would say that 489 trillion cubic feet was a 50% probability of that happening. And it could be more, it could be less. But these numbers are, I think, probably going to change with time as more and more production data comes in.
Can you put that number in perspective as far as maybe what the U.S. is doing?
The U.S. presently uses 23 trillion cubic feet of natural gas. Petroleum contributes something like 37% of all the energy, and coal 22%. So there are figures like this. Let's suppose the United States continues using natural gas at its present rate, 23 trillion cubic feet a year. Then we can take the number 480 and figure that there's somewhere in the order of 20-year supply of natural gas to power all of the United States for everything it did, just from that gas in the Marcellus alone. Pretty spectacular.
It is a big number. Terry, thank you. And don't forget to join us again for the next clip with Dr. Terry Engelder.